Hi everyone, good morning, good afternoon, good evening. Thank you for joining us from wherever in the world you are. We hope you're safe at this time. Welcome to the online MuleSoft Meetup. My name is Royston Lobo. I'm one of the co-leaders of the Meetup group. Today we have Sanjana Verma and Amar Salah joining us to talk about the COVID-19 data platform. We also have Dominic Masters who will be facilitating Q&A. So if you have any questions, please pop them onto the chat within YouTube, and Dom and I will be monitoring that chat and we'll be asking questions on your behalf through the session. The session will be recorded and will be available on YouTube and the event page afterwards. So we'll take care of that for you. With that, Sanjana, if you're able to unmute yourself and speak up, please take it away.
Thanks, Royston, and hello, Meetup. As Royston said, good morning, good afternoon, and good evening from wherever in the world you're joining us. My name is Sanjana Verma. For those of you who don't know me, I'm a product manager at MuleSoft, and I've had the pleasure of participating on this project known as the COVID-19 data platform. If we weren't in COVID times, you may find me flying back and forth between Buenos Aires, Argentina. But right now I'm currently in San Francisco. I'll give it to my partner, Amr, to introduce himself.
Thanks, Sajna. Hi, everyone. My name is Amr Salah, and I'm part of the APEC team. It was my pleasure to join the fantastic team, COVID-19 data platform team. And same as Sanjana said, in different times without Corona, you would meet me from New Zealand. However, I'm stuck in Egypt for about 4 months now. So very good, very early good morning. It's about 4 a.m. So forgive me for any glitches, please. And yeah, I will hand it over back to Sanjana to talk to us about the COVID-19 data platform.
Thanks, Amr, and thank you for joining so early in the morning. What we're really excited about is the COVID-19 data platform was a really, really good way for us to drink our own champagne and actually use the MuleSoft methodology to build out a fully scalable and reliable data platform, all under 5 weeks. So today what we wanted to talk you through is actually how we built this out and how we were able to actually build the real-time automations and data processing all through MuleSoft-based APIs. So what we're really excited about is actually to show you us drinking our own champagne. Now, the problem that we faced was when we started as just regular people who just happened to know data, when we were looking at all of the different data sources that were being reported around the world about COVID, they kind of said the same thing, but they said it in very different ways. For example, one data source, perhaps the EU CDC, they would report the infected count. However, here in the States, they would say how many people are sick, versus another data source somewhere else would actually be reporting how many people were hospitalized. But all three of those actually meant how many people were infected with COVID on that particular day. What we realized was that every single data source would be saying the same things with slightly different attributes and slightly different names. So what we were able to do was build out the COVID-19 data platform as a globalized data dictionary to actually automate the way you say the same things. So for example, if it's even something as simple as date, these files are CSV files, Excel files, maybe even JSON-based data tracking. And they would say these attributes slightly differently. Now we were able to actually create a data dictionary that would allow us to have a standard way of querying for the same amount of data. So what we built was the COVID-19 data platform. We were able to go and actually source and curate specific data sources that were capturing key metrics like new cases, the survival rates, resource utilization. And given the importance of that data, we wanted to ensure that it could pass through an automatic pipeline that was trustworthy, secure, and allowed easy accessibility to anybody who needed it. So it ultimately is a tightly regulated data pipeline with a data warehouse and set of APIs such that you or any organization could make critical decisions and understand how the spread of COVID is happening right around you. And we did this and opened it completely to anybody. So you could go onto MuleSoft Exchange, just Google the COVID-19 data tracking API and actually get started with it right away. But we'll actually show you how we built it in a little bit more detail. The data platform is super exciting for us because it works by first identifying and validating key data sets. And we solicit important and relevant data sources that can be added to our global warehouse. It gets identified and validated and then curated into these accurate and reliable mappings and models. That is all normalized and it's fed through our secure set of APIs and reusable processes, all based with MuleSoft. And as these core connecting pieces of infrastructure, it gets fed into our data warehouse where it's stored and then pushed outwards in two formats, either via data visualization by Tableau or via our API. So that way, no matter what kind of person you are, if you're a developer, if you're a data scientist, if you're a person who just wants to look up how COVID is around you, you can see it in whichever format works for you best. So we specifically wanted to share a little bit about how we were able to go through this project. There was an enormous amount of pre-work that went into building the applications and the application network that came with it. And so we're going to take you through a little bit of our architecture design, a little bit of our user acceptance testing design. In another meetup, we'll actually be doing a specific deep dive and intense look at all of the data weave that we use to actually host our normalizations. Then we'll tell you a little bit more about our data quality control process, how we were able to do testing, ensure everything was sent and shared with security and reliability, as well as meeting our edge cases and use cases, and then how we were able to work with Tableau. So at a really high level, these are the tools, techniques, and technologies we were able to use with Anypoint platform. We built a lot of APIs. We were able to share and consume them really quickly. We were able to use a broad set of technologies as well, both with MuleSoft, with drivers, and also optimizing with certain other open software development lifecycle components based out in the broader community, like Git, a CDN hosted by Akamai. And then in terms of the architecture techniques we used batch processing, ETL and ELT processing, event-driven architecture, and application caching all together to make this happen. So I showed you a really long process diagram. I'm going to cut it down for you and show you exactly what we were dealing with in April, specifically trying to get 3 data sources in to our pipeline from the EU CDC, from the New York Times, and from the COVID tracking project. And we knew we also had 2 other data sources coming in from COVID Act Now and USA Facts. So these broadly were the types of data that were coming into our platform. There was a bunch of public health data, specifically how many people are sick around me, how many people have died from COVID in this country. Then projection data with it. Where is my county, my province, my country going in terms of COVID infection count? We were also looking at non-pharmaceutical intervention data. That's also in regular layman terms, it's what types of government policies are in place right now for COVID and COVID tracking. What regulations like wearing a mask or travel restrictions or school closures are happening. Then the last type of data that we are really excited to be looking at and gathering is around medical resource data. How much PPE is in that state? How many ICU or ventilator capacity is in that state? And then we took all of those different data types and normalized them with APIs. And we wanted to maximize the open consumption and broaden our expectations of how this API would be available and usable. So we developed it on Mule4 and chose the cloud first deployment model and deployed onto Cloud Hub. So just a really quick overview about our design, and then I'm going to hand it over to Amir to actually take us through how we worked through the API-led architecture here. But we were able to reuse a lot of the components that we built. That helped us move faster than we originally had intended. And by taking the API design approach and using these reusable APIs, we were able to scale out our platform to accommodate from 3 data sources to 12 really, really quickly. So Amir, I'll hand it over to you now.
Thanks, Sanjana, and hello again, everyone. So first, let me talk about, I will take it in a slow pace, given the amount of information we need to give, in case you need to capture anything. And the second, I will explain it in a form of problem statements. But first, I would like for people that didn't make API-led model before, this is how we say about the API-led model connectivity. It consists of 3 layers, and each layer of those is responsible for particular functions. And this API-led model actually is given and enable a lot of scalability and building dynamic solution that can scale on a grow pace. So first, let's start with the system layer. Our first problem statement, as Sanjana mentioned, we wanted to unlock a lot amount of data from the data sources, from the backend systems. And those data sources, just for explanation, I will start with those 3 APIs, COVID tracking, EU-CDC, and New York Times. Given the amount of information we are working with, and this means you could have a payload about 77 megabytes for the history data for last 6 months, and maybe for projection for a coming 6 months as well, and today. With this huge amount of data, there was inconsistency between those APIs. And this was the first challenge, how we could come with a data dictionary that helped us to provide a unified data model. So with the help of the Salesforce architects, we were able to have a data dictionary that Sanjana will take you through later. And this data dictionary was actually normalized and unified the data model across the all data sources we have. The greatness of this data dictionary, it was able to grow and scale from just 3 APIs to 15, and it's still growing. So this is where system layer was helping us. Can you go to next, please, Sanjana? The next problem statement is to gather all the data sources in one place and make it publicly available so it can be used by different systems, internally and externally as well. And this is where we had another system API to deal with the Snowflake. And Snowflake was helping us as a cloud data warehouse service to gather all the data we have in one place. So it can be single source or single source of truth, sorry. And of course, with the system layer, unlocking the data, unifying the data model, and building one place for all the data, we needed a feature or capability within our platform. And this capability means to do the orchestration and run the daily or even frequently changes, capturing the frequently changes from the different data sources. And this is where process layer role comes. So next, please, Sanjana. So in process layer, as we see here, we have built a dynamic solution, and it was really a great team. And this is what I like about this solution, that we started with this architecture. It wasn't in our mind. We revisited this architecture 7 times in 4 weeks. And we had to size it twice to understand more about the cloud deployment performance. But finally, we were able to build a process API functionality and build a solution that scaled dynamically from 3 data sources to 15, and it's still scaling with the same capabilities. And in those capabilities, we were able to do a daily or frequently calls to all the data sources at the same time. I will talk a bit more in deep about how this works later. And also integrating with the Snowflake to push the data. Yeah, please go ahead. And finally, we wanted to expose everything to consumers in a secure way. And this where we have the experience layer that expose our functionality to the public consumer in a secure way, enforcing the credentials that can be used for onboarding customers. On the other side, if you look down the system layer, you see the Snowflakes was also single source of truth for other systems like Tableau for creating the visualizing of the data, and Sanjana will explain more about this, and for other systems as well. And this was just a part of what we have built. If we go to the next slide, we will see how are we able to scale even with about 11 data sources and skill scaling. we have a problem statement, more problem statements that I will talk about it in later in details. But for now, I will just explain one more. We talked about data inconsistency between the system APIs. But what about the data inconsistency in single data source? And this basically means, as Sanjana explained before, we have different data sources, and each data source we're coming from JSON or CSV, and sometimes some data sources are combining both. And of course, DataWave was a very efficient tool using the reusable functions and all the streaming data flow to build and normalize the data into a unified data dictionary and make them out to the JSON format for other systems. But also the challenge we had when we were building this solution, all the data sources were in early stage of their development as well. And the data sources expert were releasing a daily versions of their data sources. And this means today you have this count to have the number of dishes. But tomorrow you have a different attribute name, which is number of dishes. And after tomorrow, you have just dishes. And to ensure the data quality control, we had to build another API that's guarantee or go over the structure on a daily basis and compare them and make sure we are following the same consistent approach. And this is what we call system and checker system API. This one is system API. And thank you, Sanjana, for capturing this. Okay, so I will hand it over again to Sanjana to talk about the data dictionary, and later I will take you through more deep details on the technical side on how this were integrated together. It's over to you,
Thanks,
Sanjana.
Amir. Thank you. But exactly like how Amir mentioned, a lot of the power of how we were able to do this was reusing a set of reusable data weave functions as well, which is why we're very excited to take you through that, hopefully in another meetup. But the gist and the basic part is that we knew we were getting different types of data formats. So sometimes it was coming as JSON, sometimes as CSV, sometimes it was a raw Excel file on GitHub that we found. And we wanted to ensure that we could ingest that, normalize it uniquely, and then push it out in a standardized way. We landed on pushing all the data out as a JSON to optimize for the API. Now, this is actually a little portion of the data dictionary. You'll notice on the rightmost column, these are the exact attributes that the EU CDC would be modeling for. We had to start categorizing them and start defining them to really understand what it meant. And what we realized was, if it's just people like us having to do this, we're not medical experts in the slightest. So we wanted to ensure that each of these attributes were named something that would really make a lot of sense. What I'm now showing you is the New York Times data, which was the simple 6 attributes, but it's just an example of how quickly the complexity of the data dictionary had to scale for every single data source that we adopted and for every single type of metric we wanted to ensure would get captured. So how did we actually take a data model that looks like it's just on a table and actually automate it into APIs? Well, we designed, as Amir mentioned, system APIs specific to every data source. And then we started to also templatize the API specs to include standard HTTP responses around the response messages, the error messages, perhaps authentication handling and behavior as well. Then we defined an error structure as well really easily because we wanted to have a error handling module that could help ensure client authentication details would be handled sufficiently. And this was at the time where we didn't know how we wanted to share the API. So this was really important for us to ensure that whatever and however we built this out, it could be used with as many building blocks as possible. So once we built it for one API, it could be used across all of those 11, 15 APIs that we had. So at the end of it, we ended up with 15 API specifications built for this snapshot in April. We used 2 specific API RAML fragments to ensure error handling. And then we had 1 master library defined that actually had all of the rules to our COVID data modeling dictionary. So at the end, We were able to spend about a week and a half focusing on building out all of those specs. And then we spent 3.5 weeks focusing just on implementation. 2/3 of our time of implementation was focused on data weave. The other third of our time was spent on validating the application and the API behavior to make sure that everything was flowing across our pipeline properly. Now, I'm going to hand it back to Amr, but brace yourselves. We're going to actually take you through how the flow sequence happened across the APIs to ensure that we knew what kind of behavior we had to watch for. So, Amr, I'll hand it back to you.
Thanks, Sanjana. So, team, please, now let's take it slowly and carefully. I know the sequence diagram is a bit, might be confusing, but this, as we said, we are growing a dynamic solution that's growing and scaling with no need to rework anything. And it's working in a synchronous way and in parallel. Okay, so how does it work? Let's start first. We had 2 milestones here. Let's start with milestone 1. So milestone 1 was keen to schedule frequently pull the data every day or 4 times a day. It depends, it's a configuration, and pull the data from different data sources in parallel and push them to snowflakes. So how did we do that? So first, we have system, as you see here, New York Times System API, EU CDC System API, and COVID Tracking System API. And we have a process API that's called Data Synchronization Process API. It starts with a scheduler. This scheduler was running every daily basis, because the amount of changes we faced. And to close the gap, we were running it even 4 times a day. And once it runs, it calls in parallel those 3 data sources. I'm using only 3 here for explanation. We meant those 3 APIs, the call to be asynchronous, meaning the API will not reply back to the service. And the reason is, as I explained before, some payload were about 77 mega. And we try to avoid overloading the network. And my advice here, when next time you build your data platform, watch out to the amount of data you are dealing with. And make sure don't over your platform. Give a space to scalability and to grow faster. So in here, we will using a MQ messaging systems, Anypoint MQ. And Anypoint MQ, for they don't know about it, it's a like GMS concept. It's a messaging system where you have queues and you publish your message to the queues, and you have a listener that process those messages. We had another DL which is dead letter queue. In case of failure for any of the phases, the dead letter queue will capture the error and will be processed manually. And we had frequently some error because the frequent changes in the data structure we have. As I explained before, attribute renaming or attribute is missing or new attribute is added. So from the outbound queue, the process scheduler API is calling 3 data sources. Each of data sources is pushing the message to the outbound queue, as we see here. From there, it will be picked up by the Snowflake System API, which give the data, separate them, and we will see later in more details how the Snowflakes were using streaming, batch aggregators, and batch steps to separate the data and maintaining them in batches and separate the bulks into smaller batches and pushing them to Snowflake. This was milestone 1. Everything was secured with a client enforcement policy on API Manager. Sanjana, please ahead to milestone 2. So in milestone 2, we were trying to enable the manual pushing as well. So early, we talked about the scheduler, which runs to automatically pull the data from data sources, push it to Snowflakes. But what if we need to manually add data, correct some data, or we have different data sources, can't be automated for now, so we need to push the data manually. This is what we have done here. We reused existing system we have built. And again, watch out when you build a data platform, you're not sure about how many data are you dealing with. Make sure you have a dynamic solution. Revise your architecture over and over again, as we did. So you make sure you build a scalable and dynamic solution. As you see here, we have a data contribution on the very right corner, and it's pushing the data to inbound queue. And again, we have aggregation process API, which is getting the data, aggregating them together, and pushing them to outbound queue. And the same way as we did before, Snowflake System API will pull the message from the queue and process it to Snowflake APIs. So I will take you now through a journey on how this is built on Anypoint Studio. As you see here, it's very high level. The first diagram is showing Apache steps. I will open the studio and show you. But for example, one of the things I loved actually about this, if you look to the second picture, you see this red thing. It's a COVID-19 data source system API dev. What does it mean? It means we exposed all the system APIs from data sources in a consistent way. It's kind of governated URI resource that helps us to dynamically add more data sources without touching the feature or the main capabilities. Just configuring one more data source and it will be backed up. So I will share my screen now, if you don't mind, and I will. I think this will stop your sharing, Sanjana, and
No
try to
problem.
explain a bit more, on Anypoint Studio.
Oh wow, my
So
face was
as an
moving.
example, sorry.
No worries, sorry.
Okay. As we start, I will take just first example. Following the best practice for Mule, we built multiple configuration file, and this structure is actually followed everywhere. We have one global file for configuration, one global file for error handler, and the APIs for interface, and the actual logic implementation. And this is where I want to focus. With every data source we were loading, we have three types of data. The history data, which let's say for last 6 months, the today data, and the projected data, which means the next 6 months or so. And for the history, when we work with the data, we really need to be careful on what data we are loading. We try to avoid the data network load. And this is why we use the object store to ensure if the bulk load of the data is already loaded, so we don't want to load it again. We use this feature to enable and disable the possibility of loading the bulk history over and over again, or just load it once. In early stage of the project, the history even get corrected every day. This means the number of disks could be 70 for yesterday, but they correct the data again and it becomes 71. And that's why we had to pull the data over and over. But then we have a functionality using object store flag to say if the data bulk load is already loaded before, so don't load it. And this is another problem statement. And then we pull the data from the data source. And as we said, it could be JSON, it could be CSV or Excel file. Once we pull the data, another problem statement we have talked about earlier is validating the schema. We wanted to make sure the data quality control, meaning the attribute names are the same. The attribute names we are using are not missing. And if something is added, we need to capture it. And this is where we had this validation schema, and we'll have a quick look later about it. Last but not least, for this API, we break our APIs. We break our data in smaller patches and push it to the endpoint on the queue, so it can be processed by Snowflake System API. And this is one of the system APIs, and the same scenario is followed over and over again with other system APIs. Now I'm going to talk about the capability, which was responsible for frequent calls on every day or on 4 times a day, or however you would like to schedule it. So we have this scheduler, and at the moment we run it 4 times a day. Once it runs in parallel, it calls all the existing data sources asynchronously. And that's what we see. We talked earlier about the endpoint, the red line we have discussed. It's following standard to expose all the system API. In here, we are building a dynamic call endpoint. And asynchronously, we are calling all the system APIs. Every system APIs is getting called, and until we have no more system API. It's basically a configuration here. If you want to add a new system API, you just go to the configuration file and add a new name to your system API. It was very tricky, but it's very crucial part of the application that you build it dynamically and make it scalable. Another one I want to talk about is the Snowflake, one of the main functionality we have built, which is the service was responsible for pulling the data from the queue and process it. As we see here, this is the main thing I want to discuss, the batch job. With the huge amount of data we are processing, it doesn't make sense to overload the network with about 70,000 records or even 700,000 records at a time. At the same time, the data dictionary is getting reflected on the snowflakes as well. But what does it mean? We have data dictionary that categorizing the data based on the type of the data. We could have data concerns about disaster, and this means how many people they had tests, how many deaths, the count of positive tests. Another example of the data categorization is concerned about the asset observation. And this means how many beds do we have? How many ICU is available in a particular hospital? And then we have more and more, like policy and more. So we had to consume the data, but the data, in fact, were coming in mixed way. So we had to break the data here in each batch step. Each batch step is concerned about putting the data in a particular destination. And this destination is located on a Snowflake. So how did we do that? Simply using DataWave. Let's have a quick look and how DataWave were doing great. So this is just an example of one destination, one table on the data warehouse, and it's concerned about disaster. And as we see, the data dictionary here is concerned about every single aspect. It's covering the whole attributes we need to add in this destination. And for each of the destination, we were tuning, normalizing, and pushing our data to the Snowflake in such way. DataWave actually proven to be very efficient, and it helped us a lot using the reusable functionality. Again, my advice here, when you think next time about your data platform, make sure to revisit your architecture, make sure to use efficiently the aggregators, and using the batch job in an efficient way to upload the data. Make sure you don't duplicate your data and get it clean. Last but not least is the system checker. And this is where we wanted to make sure the data quality control. And this assembly was just validating the schema. And it's just checking the difference between what we have for any of the data sources and what we are consuming at the moment. And for any changes, we just propagate an email to the people they are concerned about it and uploading a new version of the data source, capturing the new details, and scaling dynamically. So for now, I will hand it over to Sanjana to give more explanation about the operational part, and thank you for your listening. Over to you, Sanjana.
Thank you. I always love it when we get to actually be in the product. So I believe you guys can see my screen again, back to slides for a little bit, but we wanted to actually summarize and tell you that, you know, once we were able to use those implementation templates and master the transformation logic, we spent a lot of time in DataWeave and took a lot of advantage for some of the out-of-the-box capabilities like streaming. As Amr mentioned, we were dealing with a huge amount of data, and streaming helps us consolidate the resource utilization. Then, using all of the reusable functions that came with DataWave became our next greatest tool. By defining all of these reusable functions, we were able to actually parse date times better, which was actually one of the hardest things to do, especially when we were dealing with projection data, therefore dates, as well as historic data. In fact, I believe we wrote close to 42 or more specific DataWeave helper functions alone that we could use across all of the APIs. So we'll be going into data weave in a lot more detail, but I wanted to actually also tell you a little bit more about how we were able to do testing, both unit testing and user acceptance testing, because that was really, really critical. I have a kindred part to MUnit. For those of you who don't know me, I also am the product manager for MUnit. So we were able to use our newest and latest feature, the test recorder, to automate the creation of all of our unit tests. This helped us make sure that we were having sufficient code coverage and code quality as defined by MuleSoft and Salesforce standards for any kind of product that we own. And at the same time, we were learning about all of these different edge cases with how the attributes, the data sources, and the models were all changing literally within hours of each other. For example, we noticed that I'll use an arbitrary example. For example, one day the New York Times would be reporting date infected count. Then several weeks later, infected count changed to infected_CT. These might seem like human readable changes that we can just register on the fly, but to ensure that it was handled in an automated fashion, we had to check our model literally every single day. So we built out a user acceptance testing application that would run, as Amir pointed out, asynchronously, but at the same intervals for every single time we were making a batch retrieval of the data. And in case something went wrong, we were notified about it immediately. For example, it would send us the error report. Then, once we were able to confirm that we were able to automate our user acceptance testing and ensure that the data being ingested from the raw source was in the correct format as defined by our data dictionary, we were actually able to store it into the data model and then focus on how it would look on the outbound. And that's what I'm actually about to show you next. So I hope you can all see this tab that I'm about to bring over. Amir, I'm going to lean on you just to double check that you can see this. Perfect. So
I can see. Sorry, I was muted. I can see.
No worries. Thank you. So what we were able to do is actually ensure that the data that was coming into our pipeline, that was being normalized by this model, would also appear properly. So we made sure that appearance came both in the form of raw numbers and text via the API in a JSON format and via the visualizations by Tableau themselves. So this is actually the live data and the platform in action right now. Amir, you mentioned that you were in Egypt. So let's see how Egypt is doing with COVID right now. It pulls the data in right away for you and actually displays the total cases to date, the new cases that you've had in the day, and the reported deaths and the new deaths for the day. So you can actually see where the spikes were. And you can also, our next objective is to see where the hotspots are in the COVID tracking. In fact, we had access to the US data so openly that this is actually what helped inspire us to ensure that we could see everything. And the US isn't looking too great. Well done. And at the same time, if you wanted to see it in action with the API itself, we published the live API endpoint on AnyPoint Exchange. So you could see both with the Tableau visualizations, how it's trending for the day, or if you actually wanted to see the data based on the API response, you simply have to go to the API console here and choose our live endpoint. In this case, I guess, let's see how Spain is doing. And I want to see how they've been doing for the past, let's say, 5 days. We can actually send it not just against the mocking service, but we can see in the data table view how they've done over the last 5 days in terms of death count and reported count. And I guess they've been doing really well. And we can actually see all of this in real time. The beauty of about having this both in the format of an API and a visualization is that it actually helps you communicate what the API is delivering and what more you need to be looking at as you try to understand and assess how COVID is affecting you or affecting your community. So for us, nailing how we were able to deploy it after all of the testing was really important. Remember, deploying our API didn't mean just going live with the platform. It meant ensuring that it was actually usable, ensuring that all the output was actually human readable. That was really, really important to us to ensure that anybody could consume it and try to get started. And we worked really closely with Tableau to ensure that all of the data could actually be processed into that visualization automatically. So you could click around and figure out what's happening and investigate for yourself without having to write any of this custom logic. So for us, nailing how to engage with the API, with the visualization was really important. And it was a lot of balancing some of these silent implicit rules that I think we take for granted. For example, if you go into your app store on your phone, you don't really think twice about using the download button. But we had to learn and think twice about how people would use perhaps the get response button and make sure that what came out of that would be useful for you. So in the end, that meant, first of all, we realized after we published the API that we wanted to make this an open API. But why would somebody have to request access for an open API? So that quickly was something that we had to change. But we didn't actually have to change any part of our implementation in order to accommodate for that, which was really nice and easy for us. Then the other part was making sure that the live endpoint could actually be found and you could test the API directly in Exchange. So at the end of the day, we were able to actually survive a minor DDoS attack that was launched pretty much within 6 hours of us deploying the API. In all honesty, for the nerds in us, we were like, wow, we pushed out an API that somebody actually wanted to hack. And we were able to survive to tell the tale. As well, we also used a CDN to help ensure that we were able to throttle any extraneous requests. This helped us also ensure that the API was hyper responsive. We were also able to see about 150,000 unique API requests a week within the first week of our launch. Through API Manager, we're able to see that about 106 unique consumers were using the API. And we were averaging about 30,000 unique views to the Tableau visualization. We showed you that API-led architecture, but this was it in action. This is actually how our visualization and our application network came to life. So we not only were able to see all of the components that we had built, we were able to see how many we were able to reuse and from where a lot of our API traffic was. And you can actually see Amir over there in Egypt making a lot of requests to the API as we were testing it in the beginning. So all in all, I know that we're running out of time, but for us at MuleSoft, it was a really great opportunity to continue to use our own methodologies and build out something that we thought was open, usable, and available right away. In fact, we recommend if you really want to get started with this, go into Exchange. You don't even have to log in. You can use the API directly from here. I'm not even logged into any point platform and I'm showing it to you. If you want to get started and see what you can do more with this, one, you can come back and join us for our next meetup. Two, try actually building out a flow. We've built out some really cool apps with this particular API, and while we're taking Q&A, I can show you a little bit more in detail. But you can integrate this API with Slack, with Twilio, with perhaps your own native texting platform or an email provider to just send you results right away. And those are really cool, quick and easy apps to get you started in learning how to integrate, learning how to connect directly. But with that, we'd also love to know what more you think you can do with these APIs. Give us feedback. It's directly in that API portal, or let us know what you think. Reach out to us on Twitter. And hopefully, good luck coding and stay healthy and stay safe. Royston and Dom, we'll hand it back over to you now.
Thanks very much, guys. That was fantastic. We had a couple of questions that came in during the course of the session. I'll just throw it out to both of you, Sanjana and Amar. I don't know who can answer these, but we'll see how we go. So the first one is, it was great to see the publicly available APIs in Exchange, but the underlying code in AnyPoint Studio, is that publicly available at this stage?
The code itself for the API is not yet available, but all of the pieces that we used are available on Exchange publicly. So you have all the individual puzzle pieces, just not the way that they connect to each other.
Right, okay, fantastic. The next question that we had is around the object store being used to store a lot of the data. Typically, you use object store to store small amounts of data. It would seem as though you guys are storing a lot of data in object store. Have you guys run into any limits around that at this stage? And if so, how did you work around that?
Okay, so object store, it's meant to be for a small amount of data, and still it's meant to be for a amount of data, and we used it for a small amount of data. So when we talked about the bulk data, doesn't mean we loaded the whole data in object store, because it's not a database and it's not meant to be for this. We were just using flags or some variables to indicate whether those data are loaded or not. So keep using object store in the right way, using small amount of data.
Okay, so the data stored externally, you were just having a flag there as to whether you needed to reload that data from external.
Correct.
Exactly.
Correct.
Perfect. Perfect. And the last question that we had, actually quite a good one, is if you were linking into any other systems that didn't have an API available, how did you retrieve that data? Was there any human intervention involved, or screen scraping, or how did you actually get that data out so that you could then publish it through to Tableau, etc.?
Yeah, that's a really good question. And I think I'll tee up Amir to talk about it in a little bit more detail, but there was only one data source that had an API associated with it. All of the other ones were literally GitHub text files, CSV files, Excel files that were hosted on these domains naturally. So we did have to come up with some pretty unique ways to make sure that we could automate the retrieval of all of that. In the case if somebody was posting the data on GitHub, we could use the GitHub API to retrieve it. And we built the GitHub system API to ensure that it was cleaned properly before we ingested it. But in other cases, we weren't so lucky. In the beginning, especially when we were searching for data sources and curating them, we would actually download each of these CSV files manually, look at them, read it, be like, okay, this has changed, this doesn't make sense. And it was actually in that manual process that we realized if it's us doing it when it's not even our daily job to be looking at COVID data, we can't even imagine what people in the health tech industry have to be going through, or people who are actually trying to make decisions about when to, send their kids back to school. So Amir can actually talk a little bit more about how we were able to do some of that native implementation to retrieve the data.
Yeah, so as Sanjana actually answered well this question, we had some, of course, apart from the connectors we use in MuleSoft for some systems, we have some is using, you could find like data using SOAP or REST, which is great, but we found some data is loaded to GitHub, and then we had to integrate with GitHub. And for every day, we get the latest commits, like you get the commit and you see the date of the commit, and then you see the gap between this commit and the committed before. And it's like working with a code repository just to grab those data. And then other time, as Sanjana explained, we had to build our own repository for the manually pulled CSV files or Excel files and unify them. But in the same time, the data source experts were really keen to work with us as well, and sometimes to provide some automation way. And they were very supportive and helpful in providing a way. So we started early with hard way, manually pull the CSVs, manually GitHub, but also data source experts were improving. And then every day they were providing a new way to do it. And it was a challenge, but it was good that we find always a way to automate those data.
Yeah, there are plenty of web scraping APIs that you can find online as well. Plenty of CSV parsing APIs as well that can definitely assist you in this process. The thing that I think we took away from it was keeping up with the data sources is actually harder than retrieving the data sources automatically. And if there was an area for all of us to improve on when it comes to COVID data collaboration, it's definitely in keeping up with the data sources and seeing what they're tracking and seeing what they're testing and what they're looking at. But as we know, this disease, as well as how we react to it, evolve in so many different ways every single day. It's really hard for us to keep track of all of it. So.
And I'm sure that would have been tricky because you wouldn't have been notified of changes as they occurred. It would have just been a boom, something's not working as you were expecting it. Fantastic.
That's what we were when we talked about schema validation and stuff. That we in the beginning it was not easy at all. It's getting we have got to learn new things on how to deal with this mess better and better, and they also learned more on how to provide better solutions within time. So it's collaboration, as Sanjana said. It was a very collaborative at early stage, so we get to this point.
Fantastic. And another question is, obviously you're pulling data from a number of different locations, data sets, etc. Obviously, a lot of that information is publicly available. It's being used by a number of organizations around the world. Did you have to jump through any hoops, though, to get access to certain data? Or is it all just in the public domain?
Also a really good question. I think yes, as whenever you, especially if you're part of a large company, will have to jump through hoops in order to ensure that the data that you're getting is also used in a responsible and reliable manner. Obviously, we also had to make those same checks and balances, but the data is publicly available for a reason. You, hopefully based on where you are, should be able to retrieve the data and use it however you want to. The specific things that we had to look at, the 3 data sources, for example, that we mentioned in the very beginning, the New York Times, the EU CDC, and the COVID tracking project, all were available very openly. We also made it a very conscious effort to build an ethical data platform, an open data platform, such that anybody could just use it. We had absolutely no motivation to use this for like financial gain. But if you are looking at it, if you're looking at using this data for your own financial gain, that comes with its own set of data regulations, as well as legal terms and conditions that you would have to double check and use. So just be careful about that. It varies from person to person, organization to organization. But why not?
Yeah, and actually,
sorry, go ahead.
Yeah, I was just going to say one thing. It doesn't mean it's public. It doesn't mean it can be used. So we have faced also some data sources public, but it's used for research purposes. And it might not be a valid data source to use for the consistent or open platform. So actually confirming those with the data source experts, it was really important to understand more about the data and why it's created, how consistent, how valid, and all those kind of things. Also, it's really important that the data analytics team and data experts are using different models sometimes for projection, for example. And those models are, it's quite important when you work with such thing like projection to understand what model do they use, because model could be very different, and what model would you like to maintain. So yes, it's open, but with, as Sanjana said, be careful about what you use and how to use.
Yeah, I think that's valid across the board, actually. Another question just popped in. For the use cases that you've seen for the platform, what's the most interesting that you are aware of? Obviously, there's lots of other things going on behind the scenes, but what's most interesting that you're aware of?
That's a really good question, and also one that I'll say is subjective. So I think the one that excites me the most may not be the same one that excites Amr the most, but I was super excited about COVID notifications. I feel like the most obvious one had always been contact tracing. Like, let's use this API, let's see what's happening around me, and hopefully somebody can understand when I get infected, I will be added into that count. To me, that was like really broad and fetching of a use case. I was much more interested in making sure that people even knew what was happening around them. So that's why after we built out this API, I built out like 5 or 7 different apps. I'll show you one really quickly right here, which was really simple about getting information about Japan out on Slack to some of my friends who now live abroad there. And we have a little Slack group. So now they can look at what's going on in Japan every single day, and they're notified automatically. They don't actually have to go to a web source. They don't have to Google it. It's actually in their native application systems that they use on their devices. And you can do it on Twitter. You can use Twilio to text it to somebody. That was just so exciting to actually share, and maybe even, dare I even say, democratize the COVID data a little bit more and share it out. That's super exciting to me. Amir, what about you?
Yeah, as I'm in developer side, so I always excited about technology itself. So what was really exciting me during the project, it was the usage of data streaming and data wave. It was really exciting part. A lot to discover, a lot to find out, and to learn about from how to use those transformation tool like data wave, and how to stream the data in a proper way and make sure the performance and the efficiency it's always going well. I was excited always about what if we add more data sources, how it's going to behave, how all the asynchronous calls going to act on the system, and those kinds of things. So this was really exciting to me during the development phases. Yeah.
Yeah. But
Fantastic.
if you guys
I
are
still
thinking,
heard them. Yeah.
oh, well, I was going to say, if you guys are using it for any cool use cases and want to tell us and share it with us, like seriously, in the most developer way possible, tweet it at me or our team, or even on the API itself, there's actually a link if you're willing to tell us a little bit more about how you plan to use it. And we're looking forward to making sure that we can hopefully support it if we can. Dom, I'll give it back to you now.
Thanks. I've got nothing further at this stage. So unless anything else pops up in the chat, I think that's probably it for today. I'll hand it back to Royston.
I've seen another question come in. What do you see as the future of this platform?
That's good. I think two parts to it. One is COVID is one disease. It'd be super cool if, hopefully, God bless that we don't have another pandemic happen, but in the event that we do, we can switch out the word COVID with whatever that new pandemic is and get to reuse literally the exact same things that we learned. Maybe the symptoms are different because it's a different disease, but that would be really cool to me personally. I think the other part, which is a really interesting future, is what we were able to learn as we used both MuleSoft and Tableau and Salesforce all together. We were able to bring together all of these technologies to the table and use them and automate a whole bunch of manual data processing. So how can we continue to do that? I think that's going to be a really interesting part for us to continue to explore as a company and as a team.
And actually, one interesting thing, personally, I see about this platform, it brings the world attention to working with data. So this was a COVID response. So the world needs to be really proactive next time. And it could happen in health, or it could happen in education, or it could happen anywhere. So bringing the world attention to the data and how to deal with the data, how to be ready for any sort of disasters. I think this is enabling a lot of opportunities to work with data or use the data in a proper way. So we found out we have the data, but now how to use it.
Yeah, that's actually such a good way of putting it. Like, you didn't have to know how to use a Jupyter notebook all of a sudden in order to actually do a little bit of data analysis. You also didn't have to be a Python or R expert as well. And that really made a big difference in making sure that we were all a little bit more literate about COVID than we might have been otherwise. So I'm looking, yeah, Amr, really, really well put. I'm looking forward to seeing how this platform helps the data community even more broadly.
Fantastic. Thank you so much, Sanjana, Amar, and Dom, for your participation and for sharing everything that you have today. Audience has loved it. For anyone who's on the line who's interested in a recording of this session, it'll be posted on the event page in a few hours. And yeah, feel free to connect with Sanjana on Twitter. And we hope to see you at the next one. Thank you all.
Thank you.